We're going to begin our chapter 15 by discussing what is energy and the 8 different types of energy. I'm sure you can picture something that you would say has a lot of energy. Maybe it's moving fast, it's bright, it has loud sounds, and I'm sure you can picture something that doesn't have a lot of energy. It's not moving, it's pretty dull, boring, staying right where it is. But in science class we call energy the ability to do work. Work is a very funny word, and we all define work differently, but here in science we're going to define work as a product of force and distance. If we look at this weightlifter, he is lifting a dumbbell high above his head. That is the distance that it's traveling. And in order to lift that, he's putting in a lot of effort. He's pushing on it. That is a force. The end result of that bar traveling that distance is considered work. And the reason he's able to do work is because he has energy. There are 8 different types of energy. And each of these types we're going to talk a little bit more in the upcoming minutes. But before we can do that, we need to first discuss the difference between potential and kinetic energy. Potential energy is stored energy. The symbol for potential energy is PE. If you write PE on a test or any worksheet, I'm going to know that you're meaning potential energy. And kinetic energy, or KE, is the energy of movement or motion. Each of these 8 types of energy we're going to classify as either potential or kinetic. And we're going to use these keywords here of shared or stored for potential and movement for kinetic in order to remember these. Our first type of energy is radiant energy, also called electromagnetic energy. Electromagnetic energy is the movement of protons. We see our keyword movement. So movement means that this is an example of kinetic energy. We get our radiant energy from the sun. Radiant energy can be found on what's called the electromagnetic spectrum, ranging from radio waves to gamma rays. And examples include light, X-rays, which allows you to see your bones, infrared, which we see as heat, and radio waves. Here's the electromagnetic spectrum. Electromagnetic spectrum is a wave. It ranges from very large waves, where the peaks are spaced very far apart in radio waves, to very close together, where the peaks are so close they're about an atomic nucleus distance apart. What we can actually see is right here, called visible light. And this is your rainbow from red to purple. And this is what we can see as humans. The infrared range is actually seen by some animals, such as snakes, and we've invented infrared goggles, or like heat sensors that allows us to see infrared. And there's other animals, such as the hummingbird, that sees in the ultraviolet spectrum. But we can only see in this short little area that is the visible light spectrum. Our second type is electrical energy. Just like electromagnetic energy, we see this word movement. It's the movement of electrical charges. And we know that this is an example of kinetic energy. It's the movement of electrical charges or electrons. Remember that electrons are the tiny negative pieces of an atom. And we've got 2 types. We've got lightning and static electricity. We're going to talk so much more about electrical energy in our next chapter. Our third type is chemical energy. Here we see the word stored. Chemical energy is the energy stored in chemical bonds. Because we see stored, we know it's an example of potential energy. The chemical bonds are broken. Remember that bonds include things like covalent bonding and ionic bonding. And when we break these bonds, energy is released. Think about when you eat your food, your body breaks it down and it gives you energy. Things like TNT or explosives have stored energy, and the explosion breaks it apart, releasing a lot of energy. Gasoline also, what runs your car and other things, has a lot of stored chemical energy. Our next type is sound. Sound is found in waves. It's the movement of molecules in the air creating vibration. And here we saw that keyword movement. So we know this is an example of kinetic energy. Our next type is thermal. Thermal is heat. Remember that solids have molecules that move very, very slow, and liquids move about a medium speed, and gases move very, very fast. It's the tiny movement of these particles that creates what we know as heat. The more movement, the hotter it is. And I keep on using this word movement over and over again, so we can call thermal energy an example of kinetic energy, because it's the movement of the molecules inside a substance that gives us this example of thermal energy. Our next is nuclear. Think about the nuclear bomb or the atomic bomb. This is the biggest example of nuclear energy. Nuclear energy is the energy stored in the atomic nucleus. And here I'm using the word stored, so I know this is an example of potential energy. There is so much potential energy in nuclear energy. There are two types. There is fission and fusion. In fission, it is actually the breaking apart of molecules. It's the fission reaction that created the atomic bomb, or when we talk about nuclear power, such as nuclear power plants, an example of a fission reaction. And you have fusion, where we're actually combining or fusing two different molecules. This we haven't figured out how to do yet as humans, but we do know that this happens on our sun, and it's what gives us the energy of the sun. Our last type is mechanical. Mechanical energy is the energy of motion and position. And we can call mechanical energy an equation, ME equals KE plus PE. Remember we said kinetic energy is the energy of motion? Things that are just moving has kinetic energy. Think about a roller coaster traveling down the hill. It has a lot of kinetic energy. And potential energy is the energy of position. Something that's very high up might have a high amount of gravitational potential energy. It means that it has it stored, but it's not actually moving yet. I just mentioned the word gravitational potential energy. That means that we're talking about the height, how high something is up, and that gravity wants to pull it down, and that's what gives it energy. There's a second type of potential energy called elastic potential energy, and that's from something being stretched or pressed. And we're going to talk a lot more about height than we are going to talk about elastic potential energy. In mechanical energy, you have this combination of potential energy and kinetic energy. So when something goes high up, it's going to have a lot more potential energy. And when something is near the bottom or near the ground, it's going to have a lot more kinetic energy. Watch this roller coaster as it goes through. When it's at the top, right here, it has a lot of potential energy. And as it starts to go down the hill, that's replaced with kinetic energy. And as it goes up, it's potential and kinetic energy keep on balancing each other out. And we're going to talk about the conservation of energy. We're going to actually be able to calculate this and how it happens. Our last type of energy, which is really not a type of energy, it's actually a force. what we're going to talk about it a little bit here is magnetic energy. It's the attraction of objects made out of iron. So examples of things such as a compass or medical equipment or generators. And it's when things are attracted because of a magnetic pull. And those are the 8 different types of energy. Hopefully at this point you have your types of energy notes completed. If you have any questions, please do not hesitate to ask me in class.